So we're going to talk a little bit about stem and leaf plots, and basically what any kind of plot is a way to organize data in one way or another. We've got pretty much plots of lines which describe relationships between two terms, and the stem and leaf plot basically takes a set of numbers themselves describing a certain topic possibly and puts it in a visual representation. So in this case, if you were to take and turn this graph, this is a stem and leaf here, if you were to take and turn it on its side, it would look like a bar graph, and everybody's kind of been exposed to some form of a bar graph in their life, where you have a number of items moving upwards from a base set of data down here. Now, this set of data has a key to it where the 5 with the slash in between it and a 3 represents the number 53. So as we can see in this row right here, we have the numbers 30, 32, and 35, etc., etc. Now you can see a whole bunch of stuff within this. In other words, in which class or which range do you have the most set of data, and because it's organized this way, it's clear to see that most of the data is within the 50 to 60 range. And you can see the low number is a 20, the high number is a 102, etc., etc. Kind of tough to tell the average in this case. You could find the middle of the data probably pretty easily in this case. But you can definitely tell if the data is spread out or if the data is grouped tightly from these data sets. So let's go ahead and do a couple of these. So we're going to take this set of data and make a stem and leaf plot. And the big thing in these initially is organizing the data so it's easily used. So what I've done in the first case is I've organized it such that I've arranged it from smallest to largest. So I just went through and physically, and this is what I would suggest you guys do, find the smallest number, clearly that's the 56, cross that off and write it down. Then I'd find the next smallest number, which is somewhere in the 60s. Here's a 60, here's a 60, and I should have another 60 somewhere. Here's a 60 here. And then you cross those three off and list them in numeric order. And do the same throughout the whole and create yourself a list as such. Then we want to create this stem and leaf plot. So what I'm going to do is I'm going to draw a line, and I'll just draw a little T-chart over here and start putting my tens digits down. So in this case, I've got a 5, a 6, a 7, an 8, and a 9. And I'll put my key down here and say 5-1 is equal to 51. So that tells us this represents a tens digit. You don't have to write this, but because the key tells us everything, and here's the ones digit. And then I just start filling in. So I have a 56, so there's a ones digit of a 6, and I only have one number in that 50 to 60 range. From 60 to 70, I have three numbers. I have two 67s and a 69. From the 70 to 80 range, I have a 72, a 74, two 77s, and a 78. Over here, I've got an 81. Whoops. Let's do that again. Got an 81, two 82s, an 83, an 84, and an 88. And then I've got a 90, 92, 93, and 94. And there is your basic stem and leaf. And like I said, ordering it and not missing a number is the most important thing. So if you go through and identify numbers in certain ranges and then cross them off once you're done using them, I think that's the most efficient way to get these done. So now we'll make a stem and leaf again and go through without organizing it. So we'll just take and start with our smallest number, which it looks like is a 65. Cross that off, see if I have any more in the 60s. I've got a 69 right here. Got a 73. Looks like the smallest 70. And a 78. Go to 80s. I've got an 82, an 86, an 80, and an 88. So we go 80, 82, 86, 88. Cross those guys off. And I've got two 90s, 91, and a 95. Then I'll set my chart up, put in my tens digits of 6, 7, 8, and 9. Put my key down here saying 9/0 equals a 90. And then start putting my ones digits in. And I'm done. So here we're basically going to do a back-to-back stem and leaf, and what we're going to do in this case is put one set of data on one side of this column here, another set of data on the other side of that column, and then you can compare the two numbers as you're going through. Now, something that's different in this data set than was not represented in the others is we have three-digit numbers. So basically our key is going to have to include both the hundreds and the tens digits. So hopefully we'll all be within like the certain, range of numbers where we don't have to make this column too long. It looks like our smallest number is 300, going all the way to somewhere in the 340s. So basically what I'm going to do is I'll use a 3, 0, 3, 1, 3, 2, 3, 3, 3, 4, and then say 3, 2 with a 7 in it is the number 327. All right, so let's go ahead and I'll just put all the classifications of numbers over here for A. So I've got 310 as my smallest. And then in that tens range, I've got a 15, two 15s. That looks like that's it. And then I'll move to the 320s, and it looks like I've got 1, 2, 3, 4 320s. And I'm just going to do this. I'm going to put a 4 right there just to save some room. I've got two 325s. And then I've got one 330. So I go ahead for group A and I say I've got, and you can choose to do this anyways. I'm just going to go backwards. I'm going to put a 0 here, a 5, and a 5. And then here I'm going to put 3 zeros, actually 4 zeros, 2 5s. Here, put a 0. All right, and then I'll go to this data set. I've got from 3 to 310, I've got 2 numbers. And it looks like this is all in order for me, so I'm just going to go a 0 here and a 5 here. From 10 to 20, I have 2 numbers, a 0 and a 15. In this, I've got 2 zeros, a 5. I've got in the 330 range a 0 and a 5. And in the 40 range, a 0. So again, you can tell quickly and easily where most of the data is grouped in the A group and the B group. You see this set of data is more squeezed in, where this set of data is more spread out. A little easier than you could by just looking at a list. And even though these lists are in numerical order, investigating whether the spread of data is greater or less is a little more difficult by just looking at the data set rather than looking at the graph. So when we talk symmetry and skew, what we're talking about is the shape of the graph. Let's talk about a symmetric graph first. A symmetric graph If something is symmetric, then we know that it can be flipped. Like, for instance, a heart is symmetric because you can flip that heart over a line in the middle and it flips over to the other side if I would have drawn a good heart. A circle is symmetric because you can draw a line through the center and it will fold over onto itself. A rectangle is symmetric because you could draw a line down the middle one way and down the middle another way, and it flips over onto itself. This graph here appears to be symmetric because it appears to have a high middle and then two branches that are roughly equal on both sides. It's not completely symmetric because you'll notice to the right of this high point there are 4 numbers, to the left there are 3 numbers, but it looks kind of like a perfect mountain shape, if you will. Now, if you look over at the other graphs, you'll see that these graphs are a little bit skewed, is what we call them, because they are lightly loaded to one side and heavily loaded on another side. Now, you would think the heavily loaded side is the skewed side, but actually it's the light loaded side that we call the skew. So this graph is what we call left skewed, because if you were to take and turn it like it were a bar graph, the left side is light. Again, this is symmetric. This side is right skewed because, again, if you were to take and turn it on its side, the right side of it is light. Now, because the left side is light, we call that negatively skewed because negative numbers usually appear to the left. Symmetric has its own name. It's called a normal distribution. That's going to come in big time when we start talking about statistics, and that probably won't come till your senior year, but a normal distribution is big time. And then the right skewed is called positively skewed, again, because if something goes to the right, those go towards the positive direction. So we're going to take a look and classify these as either left, right, or symmetric, otherwise known as normally skewed. So in order to do all these, what I'd like to do is I'd like to turn them on their side and see what they look like. All right. So you'll see this one, if I turn it on its side, it goes up and then it runs this way, which means the light part moves to the right. So this is right hand skewed. This guy, if I turn it, it looks to be mountain shaped like so. So this is a normal distribution or symmetric. This one's a little bit different in that it only goes up on one side. So again, I would call that, because its low part down here where it runs off is to the left, I would call that left hand skewed. This one's a little bit easier because it goes up really quickly and then runs off to the right. So this is right hand skewed. Here, I would pretty much call this, even though there's a couple more things on the left-hand side than the right-hand side, it runs off pretty equally in both directions. I would call this symmetric. Likewise, this runs off to the right, so we'd call this right-hand skewed. This looks to be pretty symmetric as well. And this guy has a few running off to the left, not as much running off to the right, so we'll call this left hand skewed.